let's do a couple of problems where we look at exponential graphs and we try to find their functions. So let's try and find an equation for this graph, and the hint is that we can find something of the form y equals a to the x. And in fact, I'll find it in two forms. So in fact, let's find it either with an x or a minus x. The minus x is going to flip things left and right, which makes sense because this is not the characteristic shape for just a usual exponential function that starts low and gets big. But we're going to be able to do both of these guys. Okay, so we could really start with either one. Let's start with a to the x. Let's put it down here. We know that y is supposed to be a to the x, and the key thing is to just really kind of proceed in a very straightforward way. Plug in the x and y. There's a point on this graph that we know, and then here's another point in fact as well, but we know this point and we should be able to plug it in. I guess this point really is just a double check. Any exponential graph, if it doesn't have some modification in the front, should go through 0, 1. If it's anything of the form a to the x or b to the minus x, it should go through 0, 1. It has anything to the 0 power is 1. So that's a double check that this isn't an impossible problem. Okay, so we're going to just look at our general form. It's basically how you match a model to data. You write down your general model and you put in your data. And you see if there's any unknowns to solve for. 5 equals a to the minus 1. Oh, okay. That's equal to 1 over a. Or in other words, a is 1/5. Okay, so in other words, a equals 1/5 to the x is one way to write it. But we can again take advantage of negative powers. That's 5 to the minus 1 to the x, and use rules of exponents. That's 5 to the minus x. So you can either write it as 5 to the minus x or 1/5 to the x. Most people would usually prefer to do it this way because it looks simpler, and a minus sign isn't the world's most complicated thing. It's really less complicated than a fraction in a way. But they both work. Okay, so now let's look at another one, a little more complicated. Here it's swooping not just sort of switched left-right, but it's also flipped upside down. So it's actually swooping out into the third quadrant. And I've indicated explicitly the horizontal asymptote. Any exponential function has a horizontal asymptote. Usually it's y equals 0. Here it's y equals 3. So let's see what's been done to this function. It's some sort of exponential function that has been flipped upside down. So it's going to be a minus a to the x. And then if it was flipped upside down, it would just go up to the asymptote y equals 0, the x-axis. So it's been raised upward, and we actually know how much it's been raised upward, plus 3. Okay. Now we just have to look at this minus 1, minus 2, and use that data point. So we're going to have minus 2 equals minus unknown a to the minus 1 plus 3. And so we have minus 5 equals minus a, minus a to the minus 1. Hey, look. Again, 5 equals a to the minus 1. I purposely made it actually just a flipped version, flipped and shifted version of this guy. And so in fact, it's we just have a equals 1/5 again. And so we could write it either as y equals minus, that minus on the outside flips it upside down, and then 1/5 to the x, and then plus 3. Or, if we like negative exponents better, which people often do, minus 5 to the minus x plus 3. So notice the two minuses do very different things, as always. The minus on an x flips it left-right, and that's why it's swooping. It has this explosion on the left-hand side of the graph, and the asymptote on the right. And then the minus outside is the one that flips it upside down. So another way, if we had just done this problem, which we did, this problem up here, another way to recognize how this might be similar is notice the amount that it's growing in 1 unit. Here it's getting, here it was 1 unit away from its asymptote, here it's 5 units. So that's the growth factor. It went 1 unit away from kind of home base of the asymptote, and then it was at 5 in 1 unit in x. It's exactly the same kind of shape that this guy has. In 1 unit in x, it went from being 1 unit away from the asymptote, 2 to 3 is 1, to 5 units away. Minus 2 to 3 is 5. So that's what could tell us, hey, this is really the same exact shape, just flipped and shifted up.